Ladies and gentlemen, please welcome our next speaker, Halil Ibrahim Kalkan, presenting the topic, Building a Kubernetes Integrated Local Development Environment.
Hello, welcome everybody. I am Halil Ibrahim Kalkan. Today I will talk about how to create an efficient local development environment to develop distributed systems like microservice systems. And to do that, we will get help from Kubernetes. Let's talk about the agenda first. I will start by defining the problem why building a microservice solution or set up a development environment to create such a solution is hard. Then I will mention about some primitive solutions and then introduce a solution. I describe it as Kubernetes tunneling. I will show some existing products that is already available in the market. Some of them are already free and open source to solve this problem. And then I will explain how we have designed and implemented a solution to this same problem, just similar to existing products. And I will mention about the tools I have used, so maybe you want to implement in your own company without using an existing tool, existing product. And I will finally show a demo of the system we have created, so you will see it in action. Let's talk about me a little bit. I'm computer engineer, almost 20 years, and I have been worked in different companies as software developer, architect, and team leader. Then I have established Volosoft, currently can be called as a startup that produce tools for developers. Our most common known product is the ABP framework. It's an open source framework for .NET developers. And I typically work on multi-thread systems, distributed systems, and I'm a coder, so I work on object-oriented programming. I sometimes talk about DDD, some software architectures, and so on. So I'm very active coder, mostly working on open source projects. The ABP framework I mentioned here is already open source. The core part is open source, actually. There is some also commercial parts of it, so we can survive the company. Now you know a little bit about me. I want to know about you. Anyone worked in a microservice solution here? Okay, good. Anyone used Kubernetes in development or production environment? Okay, most of people have already used Kubernetes, great. DevOps engineers? Okay. Developers or especially backend developers? Great, I'm also backend developer, backend focused full stack developer or someone. Any .NET developer? Okay, not too much, I'm .NET developer. Okay, let's start by seeing a simple microservice solution so to realize in our minds. For a typical microservice solution, generally we have one or multiple application. For this example, we have a backend application as like for back office users or your employee, and a public website, for example, in e-commerce website that uses by the end users. If you are using backend for front-end pattern, you may have two API gateways in this setup, and typically an authentication server that is separated in the system, and some microservices behind these API gateways. These are just three examples, like a product service, ordering service, and an identity service to manage user accounts. You will typically, as an event bus, maybe RabbitMQ, Kafka, or whatever you want, whatever you are using, some other supporting infrastructure services. This is a complicated system, but actually this is very simple. when you in real life you will have much more microservices. But think that you are only responsible to develop the product microservice here. So how to run this product microservice locally in your own environment while it has many dependencies on the other systems. Think that you have a local computer using .NET, Visual Studio, doesn't matter, can be Java. When you run it locally, you will get many exceptions because no Redis connection, no SQL Server database available. Maybe it will make requests to other dependencies like authentication server, some other services. So to work this product microservice in your local environment, all these dependencies should be ready and available if you want to run and debug in your own local environment. That was a simple example, but this is, for example, Uber's microservice graph. How you can run all these systems locally to be able to develop only a single service or a few services. One way can be, maybe, you may think, create unit tests and maybe some integration tests. Then you isolate your own service from all others. Like, for example, you may mock the dependencies. For database, you may run a local database or just in-memory database to simulate the database. For infrastructures, you may create abstractions and create mock implementations for all these systems like cache, file system. Maybe you are using third-party services to send SMS, email, and so on. You can maybe somehow mock these dependencies. You may mock other service calls, like, for example, ordering service may need to call a product service to check the stock count, for example. You may need to create abstractions and fake implementations, for example. And also you need to deal with events in an isolated unit test environment. And also your service sometimes will be triggered in different ways. For example, it may receive events from other services, or it may receive API calls from the user interface or other services. So if you can think all this and create a unit test environment, this can be a good way of developing a single service in your local environment. However, to be honest, it's hard to implement and doesn't solve all the problems. For example, you may, if you want to test everything integrated, if you want to trigger your service from the user interface, or you may want to use the user interface and see how your service behave in this environment. So unit testing is good, but working your product service in a realistic environment would be better, actually, to see the problems in production. And also you need to simulate some network delays, some errors, some retries or problems of distributed transactions. If you don't know anything, if you don't use any tools, you may try to run all this on local computer. You may you open your IDE and run all the services one by one, or create a PowerShell script, for example, to run all the services with just a single CLI command. But this will not be efficient because it will consume your local resources first of all, and also it's not easy to run all these services in your local computer. Since I am a .NET developer, Microsoft provided some solutions to this problem before. They tried to introduce the type project. Before it was an experimental project, now it's retired and replaced by the .NET Aspire in the latest .NET 9. It's still in preview. .NET Aspire is an opinionated, cloud-ready stack for building observable distributed applications. It has three main components. The first one is orchestration. You set up all the dependencies of your projects, and then it can run all the system in your local environment, and sometimes in Kubernetes or Docker Compose. The second part is .NET Aspire is some components, like it has some NuGet package. If you use this NuGet package, they provide some abstractions and integrations with Redis, Postgres, SQL, and some other commonly used tools. The third part of .NET Aspire is some kind of CLI commands that make some automation while running all these systems in your local environment. It provides also a dashboard when you run all the applications in your local machine. For example, here we have just 3 applications, a web application and an API and a Redis cache. The Redis is working on a container, typically in Docker, and these are running locally. And you see all their status, you can view their logs, for example, and you can see some metrics and traces. I will not go deeper with .NET Aspire since most of the people are already not .NET developer, but this topic is mostly focused on Kubernetes solution. So what's Kubernetes? You already know what's Kubernetes actually. Kubernetes is a system or a tool that is used mostly in production environments to deploy your solution, scale your solution in a containerized system. Like you may have multiple nodes. Each node can be a physical or virtual server. You have pods running in different computers. You just describe your system. I want 5 copies of this application. That's all. You describe the state of your system. Kubernetes does everything. When a node goes down, it can restart services in different computers and so on. So this talk is not actually describing Kubernetes, but I wanted to introduce. Kubernetes best for running system in test or maybe QA or production environments, and used mostly by DevOps engineers. But for developers also uses, because they need to work with DevOps team to set up all the YAML files and so on. There is also a tool called Helm. You probably know that. When you use Helm, you can deploy all the Kubernetes system in a single Kubernetes cluster in a single command, maybe CLI command, Helm install or Helm uninstall. You can uninstall. We will also show that. Okay, Kubernetes is good for running your entire system in a production and like a black box maybe, but how it can help us in development. The idea is to run all the system in a Kubernetes cluster, all the applications, services, infrastructure services, gateways, whatever you want, and run only the product service that's responsible to build in your local computer. So when you run in your local computer, you can use your favorite IDE, you can use your tools and any other tools you are using in your local computer. And finally connect 2 environments together so they can run as a single environment and work as an integrated solution. So the question is how to establish such a system. This is a little bit virtualized. I mean, you run the product service in Visual Studio, run it locally. When the product service needs infrastructure like database, cache, or whatever, it will use the services in Kubernetes. Normally, these services are not exposed to outside of the cluster because they are, for security, they are behind the firewall. But your local computer, the product service in your local computer should access these services. And also, product service may make some async or sync communication with other services or applications in your cluster. Some of these services may not be exposed to outside again. And it's best to run the product service just like it is running in Kubernetes cluster by using the same configuration and environment variables. And vice versa. For example, ordering service may need to make a call to product service. It should redirect all the communication to your local computer. So your local running instance is triggered by the events and REST API calls, for example. To do that, there are some existing solutions. I will first mention about these solutions, then I will explain how we have built our solution. The first solution I can mention is Bridge to Kubernetes extension of Visual Studio. It's a very limited solution. It can redirect calls, like REST calls, to your local computer, but that's all. That has not much abilities. Telepresence, actually the best solution of I will mention. It does actually all. It can connect to your computer to Kubernetes cluster, redirect API calls and everything between the computers. Another solution is Garden. It has much more actually, not only for Kubernetes tunneling, that has more features. All these two products is mainly open sourced but not free. When you want to use in production, you should pay. Gefra, on the other hand, is a completely open source and free tool. To be honest, I worked with Gefra, but couldn't able to properly work by looking in documentation. So it has some problems, I think. Maybe it is fixed in next releases. However, the purpose is the same. Running your local code in your running your service in your local environment and integrate with the Kubernetes. Let's mention about the telepresence solution a little bit. As I said, it's an open source core system, but when you want to use in production, you will need an enterprise license. It basically installs some tools like a traffic manager or interception services to your Kubernetes cluster when you want to connect and tie your environments, then redirect calls to your local computer, and when your local computer needs resources in the Kubernetes, it redirects all the service calls and connections to the Kubernetes. To be able to use telepresence, you first need to install the telepresence CLI to your local computer. Then install the telepresence in your Kubernetes cluster. Actually, this is a connection step. You first target a Kubernetes cluster, then use telepresence helm install. Then it actually first installs all the traffic manager and other tools to your local computer, to your Kubernetes cluster. When you want to connect, you just type the connect command. When you do that, you will able to access all the services inside the Kubernetes, just they are running in your local computer. Then when you want to redirect calls, API calls to your local computer, you will need to use the intercept command. Finally, the intercept command is also extracting all the environment variables into a file. Then you can use that file to override your environment variables in your local computer. So when you start your local service, it just feels itself just running in a Kubernetes cluster and communicate all the services just like they are a single environment. Okay, now I will show how we have implemented this solution. We have also investigated all the solutions and now implemented our solution. We have a local development environment like just a laptop and a Kubernetes cluster that our solution is already running and up. So we can, for example, browse a user interface in this solution. It's typically handled by an ingress controller in the Kubernetes cluster, then redirected to a web application, for example. The web application typically uses an API gateway to access the underlying microservices, for example. These microservices can also communicate internally and uses some infrastructure tools like SQL Server, RabbitMQ, and so on. For this product service, you want to develop it locally. So you open this product service in your Visual Studio or favorite IDE. The tool we have created is named as AVP Studio. So I will explain how it works. When you connect to the Kubernetes cluster, it first installs an VPN server to the Kubernetes cluster and a VPN client to your local environment. Then establishes a VPN tunnel between two environments. With the help of this VPN tunnel, whenever your service needs to use a service or infrastructure service, a database, and so on, it just can run. It can just use like it's running in local computer because there is a VPN connection and redirects all the TCP connections to that cluster and makes it available in that cluster. And also it sets up a proxy server to collect some metrics and a proxy client. It collects all the HTTP calls, exceptions, logs, and some other information from all the services and infrastructure and sends to your local computer in the AVP Studio user interface. I will make a demo soon. Then AVP Studio makes changes on your host file. So in this way, you can just type a service name in your browser and access to the service in the Kubernetes cluster, even if it is not exposed to the outside. Okay, when you want to intercept a service, intercepting a service means when, for example, ordering service makes a call to that product microservice in the Kubernetes, it redirects the call to the local instance in your running in your local machine. So it sets up a proxy server and proxy client, change some service definition in the Kubernetes, and redirects calls to your running instance in Visual Studio, for example. When your service wants to use other services, it can already use the VPN connection. And finally, it manipulates the environment variables for the running instance. So overrides all environment variables that are copied from the pod running in the Kubernetes cluster. And finally, when you run the application in your local machine, it behaves just like running in the Kubernetes cluster. So I have mentioned about two operations. The first one connects, establishes a VPN tunnel, so you can access all the internal services in the cluster and can start to collect some monitoring data to track problems or get exceptions in the cluster. The second operation is interception. When you do that, it sets up a proxy server client and redirect all the traffic to your local environment, including distributed events. It overrides the environment variables and adds some DNS records to host file, so everything is ready. We have implemented many custom logic or code as you can expect, but we have used two main tools, so you can check these tools to create your own solution. The first one is WireGuard. It's a tool to create a secure VPN connection between two environments. With this WireGuard, we can able to access internal services or Kubernetes. And the second one is FRP. It's a reverse proxy to redirect traffic to your local environment. Normally, you know, when you run a service in your local environment, it starts to listen a TCP port. But this TCP port is not open to outside unless you configure your modem for NAT connection, NAT settings. But this tool can receive TCP connections from outside without needing to configure your firewall or NAT services. Now, great timing. Now see a demo to see how it works in real life. So you decide if it is easy to make such a development or not. First of all, to not lose time, I already deployed my solution to Kubernetes. You see the services like administration server, authentication server, a web application, some gateway, some tools like Grafana, Elasticsearch, and SQL Server. Services, deployments, everything is ready. So we can browse the application. This is the application. I'm logging in the application. For just this demonstration, I have created two microservices, products and orders, with just simple implementation. Products, we can create some products. We have an orders page. And you know, it's running in Kubernetes. For demonstration, I am running it on local Docker. However, it can run on Azure or any environment. This is standard Kubernetes. So I'm now opening the ABP Studio tool, and I opened the same solution in my ABP Studio tool. I will not talk much about ABP Studio because it's like product. But for the Kubernetes tab, you see all the services, all the Helm charts that's deployed to Kubernetes now. Now we have a connect button here. In the right part, you see all the services. Now they seem stopped because now we are not connected to Kubernetes. When I click the connect button, it just installs VPN to Kubernetes and establishes a secure VPN connection. So now we see all the services running in the Kubernetes. You see services, uptime. We can browse any application. For example, let's start by browsing the product service, for example. You see, we can you see that? Okay, we can browse the product service just with the service name, just like it's running in our local environment. So let's open the web application and log in here. Okay, I will create a new product. To demonstrate the development, I will prepare some data. Okay, I have created a new product. It's called product 3. And I will create a new order. From the product tree, you see the order. When you go here, you see the stock count is decreased to 95 because of when we place an order, an event is published and product service catched it and decreased the stock count. Now create another product. With the same name. You see, the system doesn't allow to create a new product with an existing name. Okay, fine for now. Let's see all the HTTP requests performed during all these operations. Like you see, this is product service. Sorry, this is the product service call to create the product. You see the request details and there's response. So you see the error message here. So you can explore all the request headers and response headers here. The good point is that this is not like developer tools. In developer tools, you see only the request from the web application user interface to the API gateway. But here you see all the requests, including inter-service REST API calls. You can also see events. For example, when we place an order, there is an event published, named order placed, with the product ID and stock count. It's received by the product service, you see. So we can also track all the events sent and received by the services. And we can also see all the exceptions, including the exceptions throwing by the services we are using. You see all the stack trace here for detailed exception log. You see the same exception actually repeated 2 times because the first one is thrown by the product service and it is rethrown by the web application. But the exception type is different because for the product service it's kind of user-friendly exception. For example, for the web application it's a remote API call exception. Okay. If you also want to see some logs for further details, you can see product service logs. The logs written to console is available as real time here. So as you see, we can see all the applications, browse them in Kubernetes. We can see requests, events, exception logs, and some other details. Okay, let's make a development. Until now, we haven't set up anything actually in the client side in our local computer. Everything's working in Kubernetes. Now, I will intercept the service and redirect traffic to my local machine. I'm right-clicking here and enable interception. Okay, now it's done. You see a small symbol here. Okay, let's try to browse the product service. When I do that, let's do it on Chrome. Okay, it is not working because the product service are now redirected to my local machine, but it is not working. I'm opening the Visual Studio and starting the product service in debug mode now. Okay, now it's running in my local machine. When I return to previous page, if I press F5 for refresh, now we see it's running. When I browse this page, the request is actually sent to the Kubernetes cluster. It is then redirected back to my local machine and handled by the locally running instance of the product service. Okay, let's prove that it's really handled by my local computer. I'm adding a breakpoint here. And trying to create the same product again. You see that it hits the breakpoint in my Visual Studio. I can step through it. I can handle bugs, trace problems, and so on. Okay, we got the same exception. Until now, we didn't have any development. However, we see that we can now debug a service that is normally running in Kubernetes, but we can debug it in our local environment. Now, let's make some development. For example, I want to change that. Instead of throwing an exception, I want to just change the name by adding some random number after the product name. Okay, the code change is done. Now, I normally should stop the application and restart because this is a compiled application. However, Visual Studio has a hot reload system. If you only change the body of a method, you can just press hot load. That's all. It's now in live. Okay, let's go to the same page again. Now, I haven't, you see, closed the dialog. Pressing the save button again. You see that new code is running and it added 850 to end of the product name. Just running it fastly. You see that product now available. So the new version in our local computer is working instead of the product service in the Kubernetes cluster. Okay, now my development is done. I can stop the application. I can disable the interception. Okay, refreshing the page. It is still working because it now returned to the product service in the Kubernetes. It now runs the Kubernetes service. To prove that, let's create the same product again. You see that we are getting the same previous exception because the version in the Kubernetes was not updated. Okay, let's update it. Right-clicking the product service and redeploying it. When I do that, it uses .NET CLI to build and publish the services, then creates the Docker image and uses Helm commands to redeploy the service. It's completed, you see. Now the new version working in Kubernetes. To prove that, let's click the save button. You see that we didn't get an exception. We see the new product here working as normally. Anything else? Okay, actually demo was like that. You see that we can just redirect. We select a service, intercept it, redirect all the API calls to our local machine, and we can debug, develop, test, whatever you want, just like in local development. When our development finish, just we disable the interception. If we want commit our code, then we can redeploy the service to see in real environment if we want. Then complete the development cycle. It's actually pretty simple. Okay, my talk is over actually. Thank you for listening. If you have questions.
Applause for you, but we have a lot of questions here from the. Let's ask it verbally, first of all.
Hello, thank you for presentation. Wanted to ask only one question. While you pressed redeploy, it will be just rebuilt on your computer and then you will it will run locally, but it will have connect with Kubernetes, or under the hood you have functionality to push it to some artifactory and to trigger deploying to Kubernetes.
Yeah, good question. Okay, normally you should deploy to an artifact, then deploy from there. But it depends on the environment you are using. For Azure, it requires like that. You need an Azure container registry and so on. But for this demo, I use it local Docker desktop. Then we didn't require that. We just created a Docker local image and targeted that image as a container source, and it says deployed. So yes, you should. do that. In our tool, we have created a system to customize this kind of things with some PowerShell scripts, so you can do it.
Finally, it will be deployed to Kubernetes.
Yes, yes, definitely. If you are using, for example, Azure, it will be deployed to Azure.
Okay, we have quite a lot of questions here. And can the solution support multiple users, actually devs, to work at one? Guess it cluster at the same time.
Great question. That's something we are currently working on. The current solution is that to deploy multiple instances of the same solution to the same Kubernetes cluster, but with different namespaces. So for every developer, you may use a different Kubernetes namespace, then use this namespace to the developer, and they don't conflict. The current solution is that, but it has a cost, because if you have 100 microservices and 5 developers, then 500 microservice copies will work. We will be working to improve this solution, to understand the request is coming from a developer machine and redirect result to the same developer machine, but it has some more difficulties. We are working on that. Currently, we can do it like different namespacing.
One more question, how to develop and test front-end applications locally, avoiding CORS issue?
CORS issue, actually we haven't any, the CORS and all setup in this solution, for example, we didn't have any problem for that. For local testing, we are just set up the CORS configuration to allow local calls. Actually, it's not a real problem.
All these tools are fine and dandy, but how do you develop and test your services against different branches, releases, versions, and different dependency services?
Again, good question. For the demo I have presented, maybe it may work with the dev branch, for example. Normally, for every branch, yes, you should do that. However, for example, if you are developing a single service, for example, it's not depending other developers, then you can use the main branch in the Kubernetes cluster, because the changed code is already running in your local computer, not need to deploy it to Kubernetes. So all the new command or all the new branch can be checked out in your local machine, and the cluster can work with the main branch. So it's not actually a problem.
How to avoid data pollution issues if everyone are essentially working on the same dev environment, constantly testing and deleting data during the day?
Okay, good. If you use for data, it's I think SQL Server, for example. You are using SQL Server, creating products, deleting products, and other developers do the same. So you will conflict in the finally. However, there is a good solution for that. You can run SQL Server in your local machine, for example, and redirect all the calls to SQL Server to your local machine. Then you don't conflict.
Okay, one more question from Bernard. I really like when guys you are naming your names here in the questions, because this anonymous group, you know, it had some different meanings. If you run an application locally which connects to your database, we need an active VPN connection with WireGuard. Can telepresence still use its internal VPN client?
If you run an application locally which connects to a local, we need an active VPN connection with Wire. Okay, still use its internal VPN client. I really didn't understand the problem, but as I shown, any TCP port can be redirected to local computer without any extra effort, just with the same VPN connection.
Okay, one more question from AP. Any plans to support OpenShift?
OpenShift, not yet. We haven't worked on that.
Okay, and the last one from anonymous group. What are possibilities to integrate this into the CI/CD pipeline for the testing the service while using the actual Kubernetes cluster?
Actually, for our solution for developers, not CI/CD pipeline, it's a different story, I think. This is for simplify development workflow. That's all. Okay,
Okay.
thank you again.
Thank
very
you
much
one more time,
for
and
listening.
I would like to warm applause to our speaker. And here it's a small present from us.
Thank you very much.